let's talk about the invisible architecture that makes your internet feel, well, instant. It's called a content delivery network, or CDN for short. And trust me, without it, your online world would be a lot slower and, honestly, a lot more frustrating. So let's dive in.
I mean, really, just stop and think about that for a second. You could be on a train in Tokyo or sitting in a cafe in Buenos Aires. You hit play on a 4K movie, and it just works. How is that even possible? How does one company stream crazy high-definition video to millions of people all at the same time without creating a planet-sized traffic jam on the internet? Well, the answer is a really brilliant piece of engineering, the CDN.
So to really appreciate what CDNs do for us, we've got to travel back in time a bit to an internet without them. See, in the early days, every single website lived on a single central server somewhere in the world. This was the origin server, the one and only source of truth for all of that website's data.
Now, just picture that. You've got one server, let's say it's sitting in California, trying to handle requests from someone in Australia, someone in Germany, and literally millions of other people all at the exact same time. Every single request, for every single image, had to travel all the way across the globe to that one machine, wait its turn in line, and then travel all the way back. It created this massive global bottleneck. It was just not sustainable.
And the result of that? Well, it was an experience we've all felt at some point. That agonizing wait for a page to load. We call that high latency. The server itself could get totally overwhelmed and just crash, which would take the whole site down for everybody. And, if you were physically far away from that server, your experience was just plain worse. The whole system just wasn't built for a global audience.
So, how do you solve a global problem of distance and congestion? Well, the solution is actually pretty elegant. You don't make everyone come to you, you go to them. And that right there is the simple, powerful idea behind the content delivery network.
A CDN is pretty much exactly what it sounds like. It's a huge global network of servers. These servers, which are often called edge servers, store copies, or a cache, of a website's files. So instead of that one server back in California, you suddenly have thousands of them, all over the world, ready to deliver that content from right around your corner. And the difference this makes, it is literally night and day. Everything that was a huge problem before suddenly becomes a strength. That awful high latency, it turns into super low latency. A single point of failure becomes a highly available, really resilient network. The whole experience goes from being inconsistent and frustrating to consistently fast for everyone, everywhere. So how does this actually work in practice? Well, the real magic behind a CDN's incredible speed is a process called caching. Okay, so let's follow the journey of a single request. When you click on a link to see an image, your computer doesn't ping a server halfway across the world anymore. Instead, the internet's directory, the DNS, smartly directs your request to the CDN server that's geographically closest to you. That local server then checks its storage. If it has the image, and we call that a cache hit, boom, it's sent to you instantly. If it doesn't have it, that's a cache miss, no problem at all. The edge server just quickly grabs it from the original server, saves a copy for the next person in your area, and then sends it to you. It's a brilliant way to make sure popular content is always close by. But, it doesn't stop there. Modern CDNs are so much more than just a global hard drive. They're actually intelligent systems that are constantly optimizing how content gets delivered to make things even faster and more reliable. One of the key techniques is something called load balancing. You can think of this like a really, really efficient traffic cop at a massive intersection. If one server starts getting too busy, the CDN automatically starts redirecting new requests to other, less busy servers in the network. This whole process prevents any one part of the system from getting overwhelmed and keeps everything running nice and smooth for everyone. They also do something really clever. They make the files themselves smaller, right on the fly. Using things like gzip compression and advanced image formats, they just shrink the amount of data that actually needs to be sent across the internet. It's kind of like packing a suitcase more efficiently. The smaller and lighter it is, the faster it's going to get to its destination. Okay, and this is where things get really, really fascinating. CDNs started out as just a way to deliver static files like images and videos. But now they're evolving into these incredibly powerful computing platforms right at the edge of the internet, just milliseconds away from you. So modern CDNs have to be smart about two different kinds of content. Over on the left, you've got static content. This is stuff that doesn't change very often, like a company logo or the basic code of a website. That's easy. The CDN just stores a copy close to you. But on the right, you've got dynamic content. This is stuff that's created just for you, right in that moment, like your social media feed or personalized search results. A CDN can't store a copy of that, but what it can do is create a super fast, optimized highway for that data to travel from the origin server straight to you.
And that brings us to the next massive leap forward, edge computing. The big idea here is, what if you could run your application's code not on some central server far away, but directly on those thousands of CDN servers scattered all around the world?
Well, this changes everything. Instead of your request having to travel all the way back to the origin server just to do a simple task like checking if you're logged in, that logic can now run on an edge server that might be just a few miles away. This dramatically cuts down on delays and makes modern web applications feel incredibly, unbelievably responsive.
So, who's using this stuff? Well, pretty much every major online service you can think of. That instant streaming from Netflix, the fast-loading product pages on Amazon, the uninterrupted music you get from Spotify, it is all powered by massive, sophisticated CDNs from companies like Cloudflare, Akamai, and Amazon's own CloudFront.
Look, if you take away just 3 things from all of this, let it be these. CDNs are the backbone of the fast, modern internet because they provide low latency, which means speed, high availability, which means reliability, and global scalability, which means they can reach everyone, everywhere, without even breaking a sweat. And that leaves us with a pretty fascinating thought to end on. We started with servers that just stored files. Now, those same servers are running complex code. So if any computation can happen instantly, anywhere in the world, just milliseconds from any one of us, what kind of truly real-time, intelligent applications will that make possible next? The future is going to be incredible to watch.